So yes, let us move to the next question, that is question number 20. Question number 20. Okay, that is about finding the upper bounds and lower bounds, right? It is related to the area of rectangle. We are being given with the area of rectangle as 55.2 centimeter square, and it is written correct to 1 decimal place. The length of the rectangle is also given as 9 centimeter, and that is correct to the nearest centimeter. We have to calculate the upper bound of the width of the rectangle. We need to first find out the width of the rectangle using the area and the length, and also we need to find its upper bound. And this question is of 3 marks, guys. Be very careful. When the question is of 3 marks, we need to be very appropriate with the steps. We need to write all the relevant steps which are required to get the answer. Let us solve it. So now, guys, what is being given to us? Let us write the basics. Area of rectangle is given as 55.2 centimeter square. This is the area of the rectangle given to us. What would be the upper bound of this area? This implies that upper bound of the area, guys, the upper bound, that means the maximum value. Just below that we will get 55.2. So the upper bound will be anything just below 55.25, isn't it? Because if it is 55.25 or more, it will become 55.3, correct to 1 decimal place. So the upper bound of this area is 55.25 centimeter square. 55.25 centimeter square is the upper bound of this area. This part is clear? I hope yes. Let us move further. We are being given with the length of the rectangle. Length of the rectangle. The length of the rectangle is given to us as 9 centimeter, and this is correct to the nearest centimeter. So correct to nearest centimeter, what would be its upper bound? Let us find the upper bound of the length as well. Upper bound of the length will be, as you know, we just did it for the previous step, 9. 9.5 is that maximum value which when touched will give us more than 9. So anything below 9.5 will result into 9 centimeter. So the upper bound of this length is 9.5 centimeter. Clear? We got the upper bound of the area, we got the upper bound of the length. Now we know, as the area of the rectangle is length multiplied with its width, so width would be area of the rectangle divided by its length. So let us write it. Since width is equal to area upon length, so it would be equal to 55.25 centimeter square upon 9.5 centimeter. Right, guys? We are dividing area by the length, and let us quickly solve it. Divide it first of all. You know, 55.25 needs to be divided by 9.5. Better would be to, you know, first convert the denominator into a whole number. So in doing so, I'll multiply numerator and denominator by 10. That gives me 552.5 to be divided by 95. Isn't it? We will divide it in such a way. Let us do that. 552.5 divided by 95. You may use your calculator as well. I am doing it in my way. So 9.5, that has become 95. So sorry. Yes, 95. So first of all, 55 won't get divided by 95, that's for sure. How many times will 552 will divide, 95 will divide 552? I guess 5 times. Let us check. 95 times 5. 5 times 5 is 45, sorry 25, we get a 5 here, carry it forward 2, and 5 times 9 is 45, 45 and 2 makes it 47, right? When we subtract it, 12 minus 5 is 7, this becomes 4, so this becomes again 7, so it's 77, and then we drop down this 5, we get a point over here, so this is coming out to be 775 now. What about 8? Let us try 8. 8 times 95. 8 times 5 is 40, we get a 0, carry it forward 4, and 8 times 9 is 72, 72 and 4 is 76. So we get somewhat 5.8. Since we want it to be correct to nearest centimeter, so 1 decimal place is enough. So what is the answer that I am getting over here? It comes out to be nearly 5.8. First of all, this centimeter cancels the square of this, and we are getting 5.8 centimeter. This is the width of the rectangle. Now we will round off this width to the nearest centimeter first of all. So this implies that width is equals to 6 centimeter. How come we got this? This is by rounding it. You round it to the nearest centimeter, because 5.8 centimeter is equal to 6 centimeter when we have rounded it to the nearest centimeter. Also, what will be the upper bound of this, as we want to find the upper bound of the width of the rectangle? 6. Upper bound of it would be 6.5, isn't it? So we will write it like this. Upper bound of width is equal to 6.5 centimeter. This is what we needed to do. I'm revising it one more time for you. We have written the upper bound of the area as per the question, 55.25. Then we wrote the upper bound of the length. We got it as 9.5. We got the width by dividing area by the length. We are getting it as 5.8 centimeter. We have first converted it into nearest centimeter, as length was also in nearest centimeter. So we got the width to be in nearest centimeter as 6 centimeter. And the upper bound of it is 6.5 centimeter. This is our answer. 6.5 centimeter is the required answer, or the upper bound of the width. I hope it's clear to all of you. Please note it down for your reference. You might find similar questions in examinations. Please go through it. And then once you are done, let us move to the next question. So now the next question is about the line y is equal to x1. This is a line y equals to x1. This is intersecting a curve. The curve is y is equals to x square plus x minus 3. This line y is equal to x plus 1 intersects the curve y is equals to x square plus x minus 3 at 2 points. If I try to roughly visualize it, y is equal to x plus 1. If I take y is equals to 0, I will get x equals to minus 1 somewhere here. If I take x equals to 0, y will be 1. So it is somewhat like this. And there is one curve, and the curve might be in this shape. Okay, so it is intersecting it at 2 points. These are those 2 points. We have to find out the coordinates of those 2 points. Roughly, this is the figure of a curve. That's a quadratic equation. So the figure might be like this. And this is a straight line intersecting this curve at 2 points. So we have to find out the coordinates of these 2 points. isn't it? It's quite easy, guys. Since there is an intersection between the line segment, or I should say the line, with a curve, we can substitute the value of y, that is y equals to x plus 1, in this given equation. Y is equals to x square plus x minus 3, and then we will find out the value of x, and using it we will get the subsequent value of y. Let us solve it. Let us start doing it. Let us do this. This is of 4 marks. Let us do it properly. Equation of line is y is equals to x plus 1.